With that, I will take questions, and then thank you very much.
Thank you, Dr. Abel. Thank you for taking us with you on a journey into outer space and for helping us better understand the importance of asteroids. Asteroids can be a stepping stone to Mars and perhaps one day beyond. But understanding how they move through the solar system, through our orbit, can also protect us and save our lives and our civilization. And so thank you very much for that detailed explanation. As we go and look at how we explore outer space, I think one of the key takeaways that I got was what's really important is what happens here on Earth. And it's the cooperation and the partnership that the United States has with Japan, that the international community has in exploring the stars. It's the human connection in space exploration that is vital for success. And so thank you for spending your time with us, for sharing your time with us. And now we'd like to open the floor up to questions. We have some microphones here, and someone will bring you a microphone. And again, you can speak in Japanese or in English. So, please. Yes, right there. The first one I saw was this young man with the NASA jacket.
Hi, I'm Kotaro Tabuchi, and I'm from University of Tsukuba. And as he said, I went to Johnson Space Center, I think, when I was second grade of senior high school. And thank you for your interesting presentation. And I'd like to ask you a question about OSIRIS-REx.
Sure.
And when you take the sample from the Bennu, you will use nitrogen to correct the samples. And I'm wondering that, are there no possibilities that the nitrogen gas can change the ingredients of the sample?
Right, so the question is about the nitrogen gas that we fire into the surface to collect the sample. So one of the reasons we use nitrogen is it's a very inert gas. It doesn't react very strongly with many things. And so we can be sure that it's not going to alter the material that we collect. The other thing that we have is that we know exactly the type of nitrogen gas that we're using. So any different signatures that we find from the nitrogen gas, we know that we put there during the sample collection. They're not part of the asteroid. So it's a very good question. But we thought very carefully about the type of gas that we use, and nitrogen is the best.
Okay, thank you very much.
Sir.
Here, Suzuki from, I'm a freelance translator. Could you explain about your prospect about black patch on the venue? What material they are made? You are expecting what kind of material they are expecting?
So the question is about what type of material that we are expecting. We're hoping, we think that it may be very similar to a type of carbonaceous chondrite material. So this is a type, carbonaceous chondrites are very dark, very organic, rich, also very, potentially very water rich, some of them, meteorites that fall on Earth. We think these come from dark asteroids. And the ground-based telescope information that we have of Bennu and of Ryugu indicates that both these asteroids may have similar compositions to these type of meteorites. So we're hoping, we don't know for sure, but we're hoping that the material that we get from OSIRIS-REx is similar to the carbonaceous chondrite meteorites. May not be the same, which would be interesting and exciting, but very close. That's what we think. Of course, we may be surprised when we open the capsule, but that's what we think.
Next question.
小惑星があるというふうに見せていただいたんですけど、どうしてその10の小惑星を選んで向かっているのかというのが私の質問です。
Very good question. We chose these asteroids for several reasons. Okay. One is they have good orbits. We know where they are very well. And the orbits are very good for going to, but also coming back. Keep in mind that both of these missions are sample return missions. They have to come back. So that's number one. We needed to find asteroids that were easy to get to and come back. The second thing is we had to go to fairly big asteroids that would have what we thought would be regular material on the surface that we could collect. So we wanted to go to fairly big asteroids, several hundred meters in size. We also wanted to collect organic rich and possibly volatile rich, water rich materials. From our ground-based observations, Ryugu and Bennu have these types of materials maybe. They have the best signature of these materials. So it was a combination of factors that helped us choose these asteroids. There are some others, but these are the best for this type of mission and also this time. So, very good question.
佐賀から来ました佐久間と言います。とても面白いお話ありがとうございます。質問なんですけれども、今回、地表面とあと掘り起こせ地下面をから採取するっていうのがあるんですけど、今回そのボルドーというちょっと大きい岩、あれになんかその特別なんていうか材質があるのかっていうのが、今回その形状を見て非常に興味が出てきたんですけれども、それを何かしらの手段で探査する、資料を採取するっていうことはなんかできないのかっていうのを、今回のはやぶさ2もしくは別の方で、できないかっていうのをちょっと今後の展開というか計画に入れ込めないかっていうのをもしできれば教えていただきたいです。
So that's a very good question. We think that the idea for Hayabusa 2 is that we will not go near a boulder for safety. Right? Boulders are bad, maybe dangerous for the spacecraft. Same thing for OSIRIS-REx. However, for Ryugu, we're not sure about OSIRIS-REx yet. We still have to get there. So we still have to get to Bennu. So OSIRIS-REx, our team, we're not sure what the boulders on Bennu are like. But from the images that we see and some of our information from Hayabusa 2, it looks like some of the surface material is very similar. So it could be that the boulders are very similar to the rest of the material on Ryugu. There may be some slight differences, but not many. The nice thing is that when I say we, Hayabusa 2, takes 2 samples before, no boulder. The third sample is from the small carry-on impactor. One of the things I did not have time to say, Yoshikawa Sensei knows this very well, is that the Hayabusa 2 team does not know exactly where, when the small carrying impactor explodes, where that projectile will go. So there is a chance that next year it actually may hit a boulder and break it. Chance. I'm not saying, but the chance. And you may have many fragments, and so you can pick up the fragments.